Hello, I welcome you all to your own channel MSK Learning. Now in this video we will see the Cauchy's mean values theorem. So Cauchy's mean values theorem means what? That if f such that AB belongs to a real number and G where AB in closed interval belongs to the real number such that f and G are continuous on a closed interval a comma b and f and G are differentiable on open interval AB and g of x, that differentiation of g is not equal to 0 for x belongs to all open interval a comma b. Then there exists a point C which belongs to the open interval a and b, right, such that f of b minus f of a by g of b minus g of a is equal to f dash of c by g dash of c, right. So this is what you have. If any two function is given to you, that is f and g, right, and these are the differentiable and continuous in open into closed interval AB and open interval AB, right, and such that the g dash of x is not equal to 0, then there will be one point C on AB such that f of b minus f of a by g of b minus g of a is equal to f dash of c by g dash of c. So you have any function is given to you, right, and then you have to verify the Cauchy's mean values theorem, right. So how to verify? Let's see one example. So here we have that there is one example we will discuss, and then we try to understand how to implement the Cauchy's mean values theorem, right. So the question on the screen, that verify Cauchy's mean values theorem, for f of x is equal to x cube, right, and g of x is equal to x cube, right, in close interval 1 comma 2, right. So two function is given, f of x and g of x. So sorry, that f of x is a 2x square, both will not same, right. Okay, so f of x is equal to x square and g of x is equal to x cube in close interval 1 comma 2. So you have to verify that Cauchy's mean values theorem. So first of all we have to check whether the given function is continuous or differentiable at a closed interval AB and open interval AB. So a and b is nothing but a 1 and 2. So as it is the polynomial function, so whenever the polynomial function, it means that the polynomial function is continuous as well as differentiable at close and open interval, right. So here we go, that solution, that f of x is equal to x square, right, in where close interval 1 2, right, and g of x is equal to x cube, similarly close interval 1 2, right. So you can say that since f of x and g of x are polynomial function, right, therefore f and g are continuous on close interval 1 comma 2, right, and differentiable on open interval 1 comma 2, right. Is it or not? Then we can, what we have to check third condition, that whether g dash of x is equal to 0 or not, right. So what means, we have to differentiate that g function, right. So we can say that the two condition 1 and 2 condition is already satisfied, because it is continuous as well as it is differentiable at the close and open interval. So next we have a g dash of x is equal to what? That is 3x square, right, which not equal to 0 for x belongs to 1 comma 2, All right, so all three condition is satisfied. Then we can say there is a f and g, there exists a c belongs to a b such that f of b minus f of a by g of b minus g of a is equal to g dot f dash of c by g dash of c. Okay, now so here we go. So we can say there exist C belongs to one, C belongs to a b, right, a comma b such that what, f of b minus f of a upon g of b minus g of a by f dash of c by g dash of c. Right now, so f of b means what? That f of b is nothing but, that is f of x is equal to x square, right, in what, in closed interval 1 comma 2. So this is f of x is this one, a is 1 and b is 2. So if I say f of b is equal to what, that is 2a square, right, means 4, is it or not? Right. Then f of a is what, f of a is equal to 1a square, that is 1. All right, this we got. Similarly, g of x is equal to what, x cube, right, that in closed interval 1 comma 2. So g of x is x cube, a is 1 and b is 2. So if I say g of b is equal to what, 2 cube means 8 and g of a means 1 cube which is 1. All right, then we can say that there is exist c. So f dash of c is equal to x square, so 2x, and g dash of c is equal to 3x square, right. So now, so in terms of c, sorry, that is 2c and this is the 3c square, right. So according to Cauchy's, all three conditions are satisfied. So you can say f of b minus f of a by g of b minus g of a is equal to f dash of c by g dash of c. Okay, so f of b is what, 4 minus 1 by 8 minus 1 is equal to this is 2c by 3c square, right. 1c get cancelled, 4 minus 1 3, 8 minus 1 is 7. So am I right? Right. So this is what you have, a 3 by 7, right, is equal to 2 by 3c. So cross multiply, 9c is equal to 14, right, and c is equal to what, c is equal to 14 by 9, right. C is equal to 14 by 9 which belongs to the 1 comma 2 in open interval, right. So as the given, whatever this means, first the function f of g and g of x is given, right, that is x square and g x cube in closed interval 1 and 2. First of all, we have to check whether three conditions are satisfied or not, means it is continuous, differentiable, and g dash of x should not equal to 0. That's three condition is satisfied. Then we imply this equation, that f of b minus f of a by g of b minus g of a. We have to find out one point c. If that c is belongs to the given values, right, then it is verified. So that means 14 by 9 c value we got, that is 14 by 9. This value, it belongs to open interval 1 and 2. So it is Cauchy's mean values theorem is verified, right. So you can write hence it is verified, right. So this is how we will do the problem. Thank you.